Okay, so we're gonna start with what we call data types. As you know, your program will have to be stored in memory, and often you will be handling numbers or other types of values. So in Java, you have to specify the type of the thing that you want to store in memory. And we have what we call primitive data types. These are the fundamental types in Java, and they include 3 subtypes: the integral data types, floating point data types, and Boolean. The meaning of integral is something that is whole. So integral data types store whole numbers. And the most common type is int, which stores an integer. The value of that integer could be anywhere between this number, around from -2 billion up to +2 billion. And the amount of memory that is needed for this type is 4 bytes. Now, if you remember, a byte has 8 bits, so 4 bytes means 32 bits of memory are required to store an integer. Now, the larger the memory, that means you can store larger numbers. So sometimes you need to handle bigger numbers and the int is not enough, so there are other types like the long, which has 8 bytes of memory, and it can store very, very large numbers. You probably don't need anything larger than this in your programs. The short, which has only 2 bytes of memory. So if you only need to handle small numbers, you can use short. There's also byte, which is just 1 byte of memory. And we have char, which is used to store characters. And the reason this is considered an integral data type is because every character is stored in memory as a number. This is called character encoding. You might have heard of ASCII, which is a type of character encoding. There's also Unicode. You can easily find that on the internet. If you search the character encoding for different characters, you will find them. So for example, here I have the character encoding for A is 65. So in memory, when you want to store the character capital A, in that memory location, it will be stored as the number 65, of course, in binary. And B is 66, C is 67, and so on. So all the characters that you can type on a keyboard, they have numeric values associated with them, and that's how they are stored in memory. Even when you use numbers as characters, they also have their own numeric encoding. So the code for 0 is 48, the code for 1 is 49, and so on. And then we have small characters. For example, D has the encoding 100, E is 101, and so on. In your Java programs, you can specify a character data type by using the single quotes. So I could specify the character C, right? Or the character 1. Now this is different from the number 1, right? Even though it looks the same, but if I mean that it is a character, then in memory it's not going to be stored as 1, it's going to be stored as the code, the character encoding for 1. So that means if you try adding 1 plus 2, you're not going to get 3. We got 51 because the character encoding for 1 is 49, so 49 plus 2 will give us 51. So if you want the number 1, you have to just write it as a number without the quotes. We're going to speak more about variables later in the lecture, but for now just know that when you want to declare a variable, you have to specify the type of the variable. So for example, if you want to create a variable x and you want to store a number, you could use the type int x. And of course you have to terminate it with a semicolon. So this Java statement says, please create a variable called x, and the type of that variable is int. We need to specify the type in Java because, as I just told you, every type could have a different amount of memory allocated to it. So for an integer, we need 4 bytes. If you want a character, that data type requires 2 bytes of memory. And also characters are handled differently. The character 1 will be stored as the value 49, but the number 1 will be stored as the value 1. Okay, so these are all the integral data types. We also have the floating point data types. These allow us to store numbers that have fractions. And we have two floating point data types, float and double. Now the difference between them is the amount of memory allocated to them. And as a result, they allow different precision. So for float, it allows a precision of 6 to 7 floating point, like this. And the double has more memory, so we can have more precision, up to 15 decimal points. And finally, we have the Boolean data type. This is a special type used when you're handling logical expressions that you want to evaluate to either true or false.